Okay, class, I'm back. Finishing up the last problem dealing with compound interest. Um, as you learned, we were learning earlier the compound interest formula, and we had applied it to a problem, and now we're still dealing with compound interest here, and we will be applying that formula. Let me write it up here. A equals P times 1 plus R over N raised to the nt. That's what we have, okay? So this is what we are dealing with here in this problem. So let's read this particular one, okay? And it is saying that Becky must pay a lump sum of $6,000 in 5 years, right? What amount deposited to date, that means the present value at 3.1% compound annually, will grow to 6,000 in 5 years. Okay. So we know what the future value is going to be. It's going to be 6,000. They keep saying it, right? So the best thing is to write out all of your variables that you're going to need. Write out and give the value, and then see which one you need to find. Here, it tells us in 6 years, that's what she got to pay, but that's what it's going to be. So 6,000 is our A, that's our future value. Okay. It gives us a rate, so we know what R is. R is 3.1%, but we got to change it to a decimal, which is 0.031. That's what we have. And this is the key word to annually. So and equals 1 right there. So and equals 1, right? We know time because it says we want to know, how much is the money we got to deposit in 5 years. Like in 5 years, it'll grow to 6,000. So T is 5. The only thing we're missing here is P. P is what we're missing. So we need to know the present value. What would be if we do it now? How much do we have to deposit now? So in 5 years, it is 6,000. Okay. So we're looking for present right now. Okay. So we got everything, but we're looking for P. Okay. Now, we can plug everything in. Let's do it. Let me rewrite it. Plus R over N raised to the nt, right? So A is 6,000. We can do that, right? 6,000 equals, we don't know P right there. Then we have 1 plus R is 0.031. All of that over 1, which is N. And then we say 1 times 5. Now, let me say this to you. As much as possible, try to simplify before you do anything in the calculator, okay? So I'm going to simplify this, and I'm going to simplify that, okay? So I get 6,000, right, equals P times 1 plus 0.03, because anything 0.031, if you divide something by 1, you get that thing back, raised to the 5th. So I like that expression. That's fine, right? So what I can do next is to get P, I can take this expression and divide it each side by this expression right here and get P by itself. So it'll be 6,000 all divided by all of this. 1 point, not 1 point, excuse me. 1 plus 0.031, right? All of this raised to the 5th power, and that equals P. We could put it in the calculator like this. Now remember, when we put it in the calculator, we're dealing with money. Money only has 2 decimal places. So let's put it in the calculator, you all. Let's do calculator, all right, real quick. So we're going to do 6,000, right, divided by, now put all of that in parentheses. 1 plus 0.031, and I'm going to close this parentheses, and then I got to say raised to the 5th power, okay? Look what I get. Now, we dealing with money, so you can't go to more than 2 decimal places, which that 1 does not make that 0 go up, so it's just 60 at the end, okay? So we get that P is $5,150.60. That's what we get P is. Or currently, Becky would have to deposit $150.60 to have $6,000 in this account in 5 years. Okay? Okay. I hope everybody understand that. Okay. Now I'm not going to do part B. I'm going to actually go here. Okay. The number of the number E. We're going to talk about E, because even though we're talking about compound interest, we're talking about now continuous compounding. Talking about continuous compounding, right? Just compounding nonstop. Okay. So what do I mean by continuous compounding? I mean more interest is compounded within a given time period. And it'd be the more interest you earn in that account. So it just constantly adding to the account. Okay. You have to, it can add that many times a year, just constantly adding to your account. Interest is added to the account. So look what we had. Suppose that $1 is invested at 100% interest rate per year. Compound n times per year. Then the interest rate in decimal form is 1.0. Yes, because if you move 100% as a decimal, it just becomes 1. Okay? And the interest rate per period is 1 over n. According to the formula with P, the compound amount at the end of 1 year would be the following. A equals 1 over, or excuse me, not 1, 1 plus 1 over n, all of that raised to the n power, right? Okay? So, we trying to figure out what happens when you increase n. You remember, continuous interest added, continuous. Interest can be added to the account continuously. So, let's try these. When n is a certain number, we're going to try it and see what we get, okay? So the first one, you all, using the formula, we're going to see what A gives us. This gives us our future value, right? So basically, we're just seeing what we get, right? So this is really A right here. So just seeing. When n is 1, what do we get? What's the future going to be for it, right? Then we're going to do when n is 2. We got to do these numbers. Let's do it. So when n is 1, that's like saying, okay, 1 plus 1 over 1 raised to the 1. Look what that is. That's 2 raised to the 1, which gives us just back 2, right? Now, what about when n is 2? That means it's, 2 times per year, right? So let's plug it in. Still same formula. Look what we get. 1 plus 1 over 2 it raised to the 2. Okay? Now, let's put this in calculator. So, because a little calculator now, right? So we get, put in parentheses, 1 plus, I'm going to put this 1/2 in parentheses to do it. Okay? And then I'm going to close out this parentheses and raise it to the second power. Look what we get. 2.25, right? So we're going to get 2.25. That's what we get. Now, y'all see the pattern. We're just going to plug in now n is 5, right? So we get 1 plus 1 over 5 raised to the 5th. And I'm going to tell you what it gives because I know. So when we plug this in the calculator, we get 2.48832. Okay? It's increasing, right? Every time it's increasing some. It's increasing. So now let's do it when n is 10, right? So we're doing n is 10 now, right? Still same thing. 1 plus 1 over 10. All that. To the 10th, right? So look, right? This is what we get, 2.59374, right? You see, still increasing, right? And I can keep going, and I'm going to go to 10,000, just skip some in between, right? So we have 1 plus 1 over 10,000, right? All of that raised to the 10,000 right here on the outside equals, right? We get 2.71815, right? So still increasing again. You see that, right? What about millions? right? So look, we got 1 plus 1 over 1 million raised to the million. And that's 2.71828, right? That's what we get. Still increasing. Well, you all, as you start to see these two right here at the end, right? Y'all see they're starting to get closer. They only increase in these place value, not so much in the tenths or the hundreds, but they're increasing here. But it's getting closer and closer to a fixed number. And that fixed number is E, you all. So it gets closer and closer to what we call E. It's a fixed number, right? So let me give you what E is, everybody. E is the following. E is like pi. E is like pi, right? 2.718281828459045. That's E. And isn't pi like 3.14 and it continues, right? E is very similar to pi and there's conditions. It continues, right? Different number. It's a long number. But instead of us writing this whole number out, we use E instead of writing this 2.71 out, okay? As you see it, and we can keep going on, these numbers right here can increase. The n can increase over here. And the more n increase, the more it get closer to this. Okay, it'll get closer and closer to this. You see it get closer to this. Okay, so we see as n get bigger, it starts to approach this one particular number, right, which is E. Okay, E is a real number, you all, and it's not a variable. It's just that variable is used to represent it, but it is a number. That's just like pi is not a variable. It's a number, but we just use that symbol to represent pi, okay? So when you are referring to continuous compounding, you have to use E. You see, the more that we increase n, it became closer to a fixed number. So here we have formula for continuous compounding. That means entrants added constantly to an account, okay? Now, here's the formula. A equals the P times E raised to the RT, okay? And everybody should see E in the calculator. Here's your calculator. You have the ln, and then right above ln, you should see this. Right there, right above it, you should see that. And you would have to hit second, and then ln, and then E can come up for you, okay? But this is the formula for continuous compounding. And how do you know when to use this? It will use this word continuously. It will say continuously. That means interest is keep adding to the account continuously, okay? It will say continuously, compound continuously. This is when you know you will use the formula with E, okay? Now let's try some with compound interest, right? I'll try some. Look what it says. Suppose $5,000 is deposited in an account paying 3% interest rate compound continuously for 5 years. Find the total on the deposit at the end of 5 years. Okay? At the end of 5 years, we need to find the total. Couple of things we need here. We're not going to have n here, you all. It's compounding continuously. So you're not going to see n. You don't even see n anywhere in the formula. Okay? So let's remember here, write out everything you have. P equals 5,000. Right? R equals 3%. And that needs to go as a decimal, which is 0.03. And T equals 5 years. That's all we need. And we want to know what's the total amount in this account in 5 years. That's what we want to know. We got everything we need. So let's plug it in. A equals P times E raised to the RT. So we get 5,000 right here. E times 0.03. 0.03 times 5. Okay? And we can put that in the calculator just like that. Let's do it. Okay? 5,000. I got to hit second. Then I have to hit, what you call them, ln, and e comes up. And then I put 0.03. And it's still also in the exponent. So, right, times 5, parentheses 5. Okay, like that. Close parentheses. All right. Okay. Look what we get. 5809.17, right? 5,809.17. In 5 years, that's what you're having to count. And this is with interest compounding. Yeah, interest compounding. Okay. Continuously, sorry. This is the end.